from the equation of y equals to ax squared plus bx, what if I choose to divide everything by x? What happens to the left-hand side when I divide by x? What is left? Y over x. Quite obviously, right? Y over x equals to, what else do I have? Ax plus b. Okay, now remember, what were the constants in this equation? A and b. What are the variables? X and y, okay? Now looking at this form, and then the table of values doesn't change, right? All our x and y still the same, right? X and y, we had 2, 4, 6, and then this was 6.0, 18.8, 35.0, so on and so forth. I am now going to come up with another row. This time it is called y over x. Okay? So you literally take the y value, divide by x value. Okay, tell me, use your calculator, all start pressing. 6 divided by 2, what is that? This one only calculator. 3. 18.8 divided by 4, what do we get? 4.7. 35 divided by 6, what do we get? What? 5.8. Okay, those are in our textbook already. So on and so forth. Alright? Bear with me first. You don't know why I'm doing this? Let us consider this new equation. This one over here. If I were to plot against x, but instead of y-axis, now my axis is called y over x. Okay? Vertical and horizontal axis can be anything we like, right? Sometimes the horizontal axis is time, t. Sometimes it is m for inequalities, whatever. This time my vertical axis is y over x. Okay? And y over x is simply just take y divided by x. That's it. Now, what do you think will be the shape of this graph? Is it going to be a curve? Or is it going to be a straight line? Why do you think it will be a straight line? It is of the form y equals mx plus c? Is it? Do you agree? What does Chen Zuo mean by y equals to mx plus c? What is the m stand for? M stands for gradient, right? Okay, what does c stand for? Y-intercept. And the x and the y that he mentioned in y equals mx plus c are variables, isn't it? But then it's quite confusing. You over here also have x and y. But Chen Zuo said that it is of the form y equals to mx plus c. Quite clearly, we can see that the b and the c are related. The m and the a are related, right? And then this x over here, they are also related, isn't it? They are parallel to each other. But then this y over here, do you get uncomfortable? Because in the equation in black color, it is a small y equals to mx plus c, but then in the red color equation is y over x equals to ax plus b. So here is my proposal. Instead of calling the equation of a straight line as y equals to mx plus c, which you have learned since sec 1, we are going to call the equation of a straight line as big Y equals to m big X plus c. It is just a variable. It is just a name. Okay? Big X, big Y, they are variables. It's just a name. Okay, now, tell me, for this case, what is my value for big Y? What is my value for big Y? Y over X. Can you see that big Y is the same as y over x? Why you all say 3?
No, because they thought the
Oh no, I'm not talking about value. Okay, I said. Okay, I meant what is big Y equivalent to? It is equivalent to y over x. But y over x, it has all sorts of different values, right? Depending on the original x and y variables. Okay? Now, what is my value of m in this case? Gradient, which is a. What is my big X over here? Small x. So this is some of the terms that we need to know. Big X and small x, big Y and small y, they are different, okay? So big X is the same as small x. My y-intercept will be b. Now because it is of the form big Y equals to m big X plus c, in other words, variable equal to constant times variable plus constant. It is going to be a straight line. So based on this data that I've obtained, y over x I plot it against x. So I literally go when x equals to 2, y over x equals to 3. Okay, 1 point. So this one done. When x equals to 4, y equals to 4.7. 4.7. Okay, another point. I will literally get a straight line. Okay? And what is the equation of this straight line? Big Y equals to m big X plus C. But not good enough lah. You must tell me what does big Y refer to. So this is actually the graph of y over x equals to m small x. Because it happened that they are the same. Plus C. Okay? So you see, based on the data that I've obtained, all I needed to do was to take y divided by x. I get a different form of variable. I plot the graph, I get a straight line. Now do you have a clue of how to determine the value of b, for example? What is the value of b? Can I find the value of b from my graph? Yes or no? How? What? Okay, Chicken, what is the value? How do I find b from the graph? Find y-intercept. For this topic only, be more specific. What kind of y are you talking about? What y are you talking about? Big Y. Okay, so this is our big Y. So the big y-intercept refers to b, isn't it? So once you plot this out, do you need to calculate b? No need already. You just read off the graph. Therefore, for this topic, every time you draw a straight line, you must cut the vertical axis. So this is another term I will use. I will not say y-axis anymore. For this topic, I will never say y-axis. I will say vertical axis. I will say big y-axis. I will say horizontal axis. I will say big x-axis. I'll never ever say y and x-axis. Likewise for you, okay? So now that he's provided us with how to find b, then the question is how to find a. Because that was the original question I asked you. How to find a and b? Okay, so b done already. How to find a now? Kevin, give me a suggestion. How do we find the value of a? What does this a correspond to? The m. Okay. Okay, the gradient of okay, good. So he is saying that a, the value of a corresponds to the gradient of this straight line, which you can find a gradient after you plot a graph, isn't it? Especially so if it is a straight line, right? So the next thing you need to know is that when you, for this topic, when you plot a straight line, first you must cut the vertical axis. Second, you will need to draw a triangle, a big triangle to find the gradient. Okay? Because when you find the gradient, isn't this what you do? Right? Then you find the gradient. Okay? So in summary, the big y1 minus the big y2 over the big x1 minus the big x2. Okay? Now, in summary, what we have just done is that when you are given experimental data, okay, of the form x and y, okay, then all the data are given to you, then they tell you that, hey, the x and y, they are variables. They are related by the equation y equals to ax squared plus bx. And you are asked to find the value of a and b. You are now able to do so by converting this equation, which is a curve. This is originally a parabola. You are now going to convert this curve into a straight line, because the advantage of a straight line is that I can read the y-intercept, the big y-intercept. I can calculate gradient very easily. Okay, and I will convert it to a straight line. A straight line has the equation big Y equals to m big X plus C, where big X and big Y, they are variables. This m and this C, they are constants. And you all know what variables and constants are. Okay? So to convert this into linear form, this is known as the linear form. I need to make variable equals constant, variable plus constant. Okay? So now one of the things that we can do, and we have done, is to divide throughout by x. When I divide throughout by x, I get y over x equals to ax plus b. This is a variable. This is a constant. This is a variable. And this is a constant. Okay? Y over x is a constant. Xy is a constant. X squared is a constant. As long as it's made out of x and y, without any other constants, it is a variable. Okay? So from here, we know that as long as I plot y over x against x. Therefore, a equals to gradient. And b equals to big Y intercept, which we can obtain from graph very easily. Okay? Who is following what I'm talking about for this lesson? Okay, thank you. Put our hands. So then, are there other ways of doing it? Are there other ways of doing it? There are more than one answers. For this topic, more than one answers. I'll show you a few other answers later on. But I think right now we need to determine what are variables and constants. Okay? So first, the original variables. We've got x and y. Okay? So now I will give you some derived variables. Derived variables. That means it's a combination of your x and y. Examples. Okay? First one, y over x. We just saw it earlier on in the example. Y over x. It is made up of variables only. So this itself is a variable also. So these are options for aka options for big Y and big X. Okay, so this is one option. I'll give you another option. X squared. This is also a variable. Okay, can you think of some variables? Then I tell you whether they are considered or not. As long as it's a combination, it is a variable. Okay, I need your suggestion. Yes? XY, yes. X times Y is also a variable. Any other suggestions? X over Y, yes. Okay, Y squared. There are infinite answers, huh? Okay, X cubed, Y cubed. Come on, be creative.
X to the power y.
Oh wow, okay, X to the power Y, yes. It is a variable also. Okay, Y to the power X. Any more? You see, as long as it's a combination. Square root Y also can. Okay, square root X.
Square root x power y.
Okay, square root X power Y. What else? X square over Y square also can. Any more? Log. Log X can or not? Log X can or not? Huh? Can, right? X is a variable. Log is a function. So all I'm doing over here is I use a log with a number. So I'll generate another number. This is also a variable. Okay, Darius has x plus y squared. Also a variable. Cosine, okay. Cosine. X also can. What else? Cube root. X. Huh? Pi x. Okay, now see pi x. This one is a constant. So we shouldn't have this. Okay? So don't want this one. Any more? What? Ln x. Also can. By what binomial? There's something you haven't said yet. Something quite simple. Can x squared. Okay, can. Yeah, x and y is already here lah. What else? Yes. Huh? X factorial. No lah. No, I don't think so. Sorry. Huh? 1 over x. That's what I'm looking for. 1 over x also can, right? Then 1 over y also can. So all these are possible variables. You can see from here that you can get really creative with it. Even like log base 5x. Okay, but I'm telling you that you have to know the definitions. Alright? Let's talk about constants now. Constants are much easier. Okay, give me examples of constants. Okay, pi. What else? 1, 2. Okay, e. Any more? Log 7. Also constant, right? Log 10 is 1, okay. Log 5. Any more? Negative number can or not? Why cannot? Can negative 8. All these are constants. Okay? Any questions? So let's go back to this original question. 1 over 4 also can. Y equals to ax squared plus bx. Convert y equals to ax squared plus bx into linear form. I think we, yes? Yeah. So you see, this is the original equation. Is it linear? Is it linear? Okay. No, you all say no. How to make it linear? What did we do earlier on? We divide by x. So option number 1, divide by x equals to ax plus b. Now tell me, what is our big Y? Okay. What is our M? What is our big X? What is our C? Okay, good. Now I give you another option. Okay, how about you tell me another way? How else can we generate a linear form? Divide by y. Let's see what happens. Let's divide by y. So what do we get? 1 equals to ax squared over y plus bx over y. Okay, is this a linear form? Look carefully, is it a linear form? Or can you manipulate until a linear form? Yes, yes. What do you mean by bring over? Minus, okay, choose. Okay, so he say minus, so negative ax squared over y equals to bx over y minus 1. Is this what you're saying? The one on the left hand side. So like this, is it? And then, now what? Divide by b. Okay, so x over y equals to negative a over b, x squared over y plus 1 over b. Is this what you're saying? Do you all agree with this working so far? Is there any error mathematically? No error. Okay, now tell me, in this case, what is the big Y? X over y. Okay, what about the M? Okay, what is the big X?
X squared over y.
Okay, what is the C?
1 over b.
Okay, so you see, we have already done the graph for y over x equals to ax plus b. Avro, during his test, he is going to, from the table of values, instead of just x and y, and then we have another x over y, y over x, in our earlier case. Now Avro will have to create x over y as well as, no, not minus a over b, x squared over y, x squared over y. So he needs to create these two tables, these two rows, and he will plot this. So he is going to plot this, and how is he going to obtain the value of b, for example? How is he going to obtain the value of b? From the graph, yes. From the big y-intercept, isn't it? Because the big y-intercept is 1 over b. So let's say he plot finished already. His big y-intercept, he read off the graph. Oh, it cuts at, for example, 2. So what is his value of b? Half. Because 1 over b equals to 2. B must be equal to half. So then he will be able to get the same value of b, although he drew a different graph. Will he be able to get his gradient from his straight line? Yes, he can. So let's say he get a gradient. Oh, okay, gradient equals to 5, for example. Then he's going to put it into this part. 5 equals to negative a over b. And we found b early on is half. Right? So then he can still get his value of a. Get it? So his method also works. Whether it is more tedious or not, we'll have to see lah. Okay? Besides this, any other way to make it a linear graph? Besides dividing by y. So I've shown you 2 examples already. Besides dividing by y, what else? Divide by? Divide by a. Okay, let's see. So right now you see we are literally experimenting and seeing whether different ways, different approaches work. Let us divide by a. So y over a equals to x squared plus b over ax. So what do you do next? Do you have variable equals to constant times variable plus constant? Have or don't have? No, don't have. Okay, how about we divide by x squared? Y over x squared equals to a plus b over x. Is this of the form big Y equals to mbx plus c? Yes, sir. Okay, how? Manipulate, how? What should we do?
Big Y equals to Y over X squared.
Okay. Big Y equals to y over x squared. M equals to?
B over X. No, M is A.
Let us write it in the form big Y prime x plus c first, okay? Y over x squared equals to b over x plus a. Now tell me, big Y is quite clearly y over x squared. What is the gradient? Are you sure not?
Either way, can x be 1 over x?
Can. So Darius give you the answer already. X is 1 over x. What is m? B. What is c? This is another option, isn't it? Okay. So many options for you to choose from. So now we will practice together in class. Yeah, if you can find a simple one, I think this is rather simple. So you go for this lah. No, depends on the question. Turn with me to page 209. Okay? Again, you can do it on your foolscap, you can do it on your textbook itself, no problem. Let's look at work example 1. The non-linear equation y equals to negative ax plus b over x is non-linear. Very obviously, it is non-linear because it is not y equals mx plus c. We want to convert it into a linear form. So what are the things that we can do? Without looking at the answer, what is your suggestion? See, I got variable equals to constant times variable plus constant divide by variable. It is not yet y equals to mx plus c times x. Let us multiply by x throughout, okay? So we get xy equals to negative ax squared plus b. Is it of a linear form? Is it? Is it a linear form? Those who say yes, why? Okay, Ernest says that, what is big Y? Okay, so Ernest says that our big Y is xy. What is your m then? What is your big X? What is your C? Done. This is a linear form. Okay? Any questions? Any other suggestions you want to make for this? None? Now I want you to try dividing by x. Instead of multiplying by x, I want you to try dividing by x. Now, you have 1 minute. What do you get? So divide by y. divide by x, right? Okay, divide by x. So you get y over x equals to negative a plus b over x squared. Okay, tell me what's your big Y? Y over x. What is your gradient? Good. What is your big X? Good. What is your intercept? Very good. More practice. Practice now. By the way, on page 210, right, there is a third method. Just read. I'm sure you understand. Okay, so let us try practice now. Practice now 1. Let's do 1A first. Oh, you laugh.
What?
Okay, big Y. Okay, your M. A or B. Okay, your big X. Huh? 1 over X. Okay, and C, what is that? A. Correct? Lor? Okay, so don't doubt yourself, can.
So that's how you present our answer.
Yes, for this case, yes.
Wait, you said for this case, so say A.
For this question, yes. Yes. Zen has an alternative answer. Okay, so he says y minus x cubed equals to ax plus b. So what is your big Y? Okay, what is your M? What is your big X? What is your C? B also can lah. Also can, right? As long as the variable equal to constant times variable plus constant, that's it. Let us try B and C. So take time now to try question B and C. Oh, sorry, C and D. hx plus ky equals to xy. Now, because there are so many different answers, is there anybody who wants to share your answer? Then I check whether it's right or wrong. Just show out what you will do. Divide by x. Okay, let's divide by x. H plus ky over x equals to y. Is this a linear form already? Yes. What is let's rearrange. Y equals to ky over x plus h. So big Y equals to y. M equals to k. Big X equals to y over x, and C equals to h. Okay? Now next, part F. Anybody needs help? F? Okay? Yes? Okay, you can show me your work later. Okay, first step, what can we do over here? Times x plus q on both sides, alright? Yx plus yq equals to px. What next? Divide by y, okay. X plus q equals to p x over y. Is it linear form already?
Minus Q.
Minus q.
Bring both sides. Bring Q to the right.
Don't say only. Actually, only hold on here.
That's not wrong.
Okay, never mind, it's okay. I want to show you this working. What is the big Y then? Big Y equals to x. Okay, M equals to? P, big X equals to? X over Y, and C equals to? Negative Q. Does this part look weird to you? But does it matter? Doesn't matter. It's okay. As long as it's a variable. So if I were to plot this out, I'll be plotting x against x over y. Okay? Now practice now 2. Any question that you want me to go through? Part A, anybody needs help? B? B. Okay, let's start with B first. Y equals to ax power negative n. This is definitely not linear. Because my x has a power. negative n, where n is a constant. So what shall we do on both sides?
Log x.
Divide by a, sure. Y over a equals to x power negative n. Then what? Flip. Oh, okay. A over y equals to x to the power n. Then? Okay, so you take log on both sides, is it? Okay, log here and log here.
Log x. Change to log.
Oh, change to log form. So what do you have? And log base x a over y. And then? Log base x a minus log base x y. What? Wait, what? One more time, one more time.
I just take log x. Can I do part?
Log a over log x. Equals to n, okay. Times log x, okay. Log a minus log y equals to n log x. And then? Oh. Negative n log x plus log a. Right? Okay, all your steps are correct. What is your big Y? Log y. Your big X, okay, your M. Negative N. Your big X. And your C. Okay, correct. Anybody else got another answer? Anybody else?
Actually, just, we just do it step two.
Okay, April. April has a suggestion. Come, let's start.
You just make everything log lah.
Tell me, tell me.
You take the y equals to ax power negative n. Then you just log the entire thing.
Log the entire thing. Log like that.
Yeah. No. Log y
Ah.
equals to log.
Log y.
Yeah, take log on both sides.
Okay, take log on both sides. Ax power negative n, and then?
Yeah, then you log y
Yeah, log y
equals to log a plus log x.
equals to log a plus
Log x power negative.
log x power negative n,
Yeah.
and
you
then
just put the n.
log a minus n log x.
Yeah.
Same answer, no? Look like the same, right?
M is negative and yeah, this is the same.
Yeah, it's the same lah. You see, I give you 100 marks for your effort, but really can do it like that only, okay? Yeah, it's the same. Which means his handling of the laws are very good. In this example, he used a lot of different laws, and he used them correctly. But a tip for you, for this one, you just take log on both sides. Then if you see, for example, e to the power of something, let's take a look at practice now 2a. For example, y equals to p e power qx. When you see the e, what should we do? Take ln on both sides. So ln y equals to ln p plus ln e qx equals to ln p plus qx, ln y. So our big Y equals to ln y, our m equals to q, our big X equals to x, and our c equals to ln p. Okay? Zachary, following? Okay, now practice now 2. Anybody needs help for part C? You need help for part C? Okay, so a over y equals to b power x. Again, I've got power. So what shall we do for both sides? Log, take log. So log a over y equals to x log b. What next? Huh? Log a minus log y x log b. Then what? What next? What should we do next? This one from here can get an answer already, is it? But can you help me arrange into variable equals to constant times variable plus constant first? Log y equals to? Okay, then plus log a. So our big Y equals to log Y. Our M equals to negative log B. Big X equals to, and C equals to log A. Yes. The big Y can be X log B. Log B is a constant.
Shouldn't be at big X be negative X?
No. Okay, our variable only can have variable, constant only can have constant. Huh? So your homework is practice now 1 and practice now 2. You do it properly on a piece of foolscap. Every single question. We've gone through most of them already, yeah? Okay, so not difficult. Just make sure you know what are variables and what are constants. Because this is going to be important for 7.3 and 7.4.